Many of us have grown up with the idea that Earth simply revolves around the sun, which stays still in space, but in reality the big picture is much more complicated and fascinating. As we delve deeper into how Earth actually moves through the galaxy, we'll find that our planet not only revolves around the sun, but is dashing through space in an incredible speed at the same time, along with our entire solar system. But what if we told you that this movement could be connected to some of the universe's greatest mysteries? For instance, scientific hypothesis suggests that Earth's movement through the galaxy may expose us to cosmic rays which would cause genetic mutations and contribute to the mass extinction of life. Furthermore, changes in our planet's orbit around the sun may affect the environment, which could lead to catastrophic changes such as another ice age. For starters, imagine that you're in an airplane that's flying at a constant speed and altitude. While in it, you won't be able to tell how fast you're going or even if you're moving at all. From your point of view, it seems that only the world outside is moving. However, someone on the ground watching a passing aircraft will perceive its movement relative to their own stationary position. This outline, which was first outlined by Galileo Galilean, is 1632, book The Dialogue Concerning the Two Chief World Systems. When viewed from within our star system, as we all know, the planets orbit the sun. However, with the broader consideration of things, we can see a completely different picture. Solar system is constantly moving in a spiral through the expanse of our galaxy. One of the best-known examples of relative motion within our solar system is Earth's revolution around the sun. Earth's orbit is not a perfect circle but rather an ellipse with the sun as one of its foci. When Earth is closest to the sun, it is said to be at perihelion, and that the farthest point in its orbit in relation to the sun is known as aphelion. These 2 points occur at regular intervals. Earth reaches perihelion around January 3rd, and aphelion around July 4th, which is evident with the seasonal changes of the weather, the usual depiction of the solar system with the sun and the center and the planet revolving around it. Well, that's not a completely accurate representation. You see, the planets don't just revolve around the sun, but they also pull it in, causing it to shift. For example, the gas giants Jupiter and Saturn have a particularly strong gravitational influence on the Sun and Earth, which causes small changes in the shape and orientation of their orbits. Over time, these subtle changes in Earth's orbit can accumulate, leading to long-term changes in the planet's climate and overall environment. These changes are known as Milankovitch cycles. One of the aspects of the Milankovitch cycles is the change in the tilt of the Earth's axis, which shifts from about 22 to 24.5 degrees in a cycle of about 41,000 years. Let's face it, Earth's movement pattern within the solar system is very complex. However, its movement through the galaxy is even more intricate. The Milky Way galaxy is a massive and complex system, which includes a vast amount of stars, gas, and dust spanning across over 100,000 light-years in diameter. One of the most exciting aspects of our galaxy is its rotation like a huge spinning windmill. The galaxy's spiral arms trail along as it spins. This rotation makes the stars and gas in the galaxy move in circular orbits around the galactic center. Earth is located in one of the spiral arms of the galaxy, about 25,000 light-years from its center. In the solar system, there are only a few bodies that have to be taken into account in terms of gravity, and the Sun is the dominant celestial body. Just as Earth orbits the Sun revolves around the center of the Milky Way galaxy at a speed of about 143 miles per second, completing one orbit in almost 230 million years. This cosmic journey takes the Sun, and therefore also Earth, through different regions of the galaxy. Interestingly, the stars in the inner regions of the galaxy move faster than the stars in the outer regions, due to the fact that the parts closer to the center of the galaxy have more mass, therefore a stronger gravitational pull. This difference in speed is akin to the way planets closer to the Sun move faster along their orbits. Taking an average of how these stars move relative to us, we can deduct that the Sun is drifting forward at the speed of about 3.1 miles per second in towards the galactic center, at a speed of about 5 miles per second, and up and out of the galactic disk at about 4.4 miles per second. The orbit of the Sun around the center of the galaxy is not perfectly circular either. Instead, it follows a slightly elliptical path, oscillating above and below the galactic plane. It completes a full oscillation approximately once every 60 million years. The vertical oscillation is more than just a peculiar phenomenon. Some astronomers support the Shiba hypothesis and believe that it can be directly related to mass extinctions on Earth, since the center of the disk is a more dangerous place for the solar system due to the higher density of stars and the radiation they emit. The motion of the stars can be defined in terms of their proper motion, which refers to the star's visible motion across the sky. Over time, proper motion is caused by the movement of stars in space relative to the Sun. It's usually measured in arc-seconds per year. Due to Earth's movement around the Sun, the apparent positions of nearby stars in the night sky change slightly over time. This effect is known as parallax. It happens due to the fact that at different times of the year, Earth is in a different position in its orbit. Now that we have a breathtaking picture of the way our solar system actually moves through the galaxy, one question remains: how do we move through the universe as a whole? As it turns out, the Milky Way is not alone in its travels. Our galaxy is constantly pulled by the gravitational fields of various masses surrounding it. We're currently racing towards the Andromeda Galaxy at the speed of a couple of 100 miles per second. But that's not all. The Milky Way is part of a group of galaxies called the Local Group, which includes more than 54 other galaxies, including our nearest neighbor, the Andromeda Galaxy. The Local Group, along with many other groups and clusters of galaxy, is moving towards a mysterious superdensity in a supercluster of galaxies known as the Great Attractor. The Great Attractor is a region of space about 150 million light-years away, and its gravitational attraction is so strong that it influences the motion of galaxies within hundreds of millions of light-years. As a result, the Local Group is pulled towards the Great Attractor at a speed of about 373 miles per second. However, this movement is still not the last of Earth's movement in the universe. Our entire universe is expanding, and as a result, all the galaxies in it are moving away from each other. This expansion is not a movement in space, but rather a stretching of space itself. Despite all of this motion, we can still use the cosmic microwave background radiation as a frame of reference for determining our speed relative to the rest of the universe. This radiation, which is the residual heat of the Big Bang, permeates the entire universe and is almost uniform in all directions. By measuring tiny variations in this radiation, scientists have determined that Earth and our entire solar system are moving through the universe at about 229 miles per second relative to the cosmic microwave background radiation. At this point, it's no longer a stunning revelation to anyone that Earth is far from stationary, but rather a tiny but important part of a complex system of celestial movements. The pronounced complexity of the motion of our planet is an impressively complex phenomenon. First, our planet gracefully orbits the radiant sun as it has for billions of years, but that's just the tip of the iceberg. The solar system, which our planet is a part of, also moves through the vast expanses of the Milky Way galaxy, rushing forward at incredible speed and leaving a corkscrew pattern behind it. And that's still not all. The Milky Way is part of a galactic congregation known as the Local Group. In conclusion, Earth is not just a rock flying through space, it's part of a grand scheme, a web of cosmic movements both intricate and awe-inspiring. We're just a tiny speck of dust in the vastness of this universe, but the movement of our planet is an integral part of the puzzle that is space.